Start?
Are we good?
I think we're ready to start. Okay, well, good afternoon, everyone, and welcome to this session on what's new in the AWS SDK for .NET. My name is Steve Roberts. With me is Norm Johansson.
Hi, everybody.
We're both developers at AWS, specifically in the team responsible for the SDK for .NET, the Toolkit for Visual Studio, and the tools for Windows PowerShell. So today, we're going to be looking at primarily what's new in the SDK, obviously by the title. What have we added? Uh-oh, my code monkey's fallen asleep already.
It's because you tricked me.
This is not a good start.
We're good now. Well, no, I guess we're not good. I changed the slide.
Okay, I'm going to carry on talking anyway while he sorts the mess out, which is about the way things usually happen. So today we're going to be concentrating primarily on the SDK. So things have been added in the last 12 months. So we've got some new handling for credentials, for example, that makes it really easy, super convenient for handling local development scenarios and deployment without needing to expose credentials anywhere in your application or your source code repositories. Some new libraries that we have for handling communication with S3 Link and DynamoDB, two services that people tend to use together. And also a new Elasticache.
I'm going rogue.
Okay, it's going rogue. Thinking outside the box.
That's what we do.
What we do. And some new, a new extension library for working with Amazon Elasticache. So although we're concentrating primarily on the SDK, we are going to be showing some of the toolkit for Visual Studio and also some Windows PowerShell. So having mentioned the tools in the SDK, let's get the big picture of how all these fit together. And unsurprisingly, I suspect from our point of view, the SDK is the center of our universe. So it's built for multiple platforms, including .NET 3.5, for those of you that have not moved to the latest and greatest versions of .NET. At its basis level, the SDK exposes all of the AWS services in a common and consistent manner in what we call the Service Client API layer. It also contains a variety of higher-level abstractions and helper utilities. New for 2014 is a VM import class that lets you take virtual machine images and disk volumes and import them to Amazon EC2. It does all the heavy lifting through Amazon S3 for you using C#. External to the SDK, we have the tools, so PowerShell, Toolkit, a couple of extension libraries in NuGet. These tools are built using the exact same version of the SDK that we ship publicly. So everything that our applications can do, your applications can do. In fact, if you're a PowerShell user and you've used the new import commandlets, they simply make calls to the VM import class inside the SDK. So I sense that my co-presenter is itching to get started on a demo. So Norm, what have you got for us to start?
OK. So the first thing we're going to talk about is creating those service clients that Steve mentioned and how we can manage credentials when we want to create those clients. So the SDK consists of about 35 service clients. I think after the last two keynotes, we're going to hit the 40 range. And to create a service client, we need to pass in the AWS Access Key ID and your secret key. As well as we need to specify which of the AWS regions we want to connect to, so we can access your AWS resources or create new resources in those regions. Once you have that service client, it has a one-to-one mapping of all of the service operations. And you simply create a request object, set all the required parameters on there and any additional optional parameters, and you're going to get back a response object from the operation, and that contains all the information the service returned. Here, in this case, we're calling the run instance method, so we're going to get back the instance type ID, or excuse me, the instance ID. So let's switch into code and see what that's like. So here I've just got your basic console application. I've already added our AWS SDK via NuGet. And so to get started, we're going to start adding some namespaces. So the first thing we're going to do is we're going to add the Amazon namespace. And this is the namespace that contains all the constants for all the AWS regions that we want to use. Then I want to use EC2, so I'm going to add EC2 namespace. This has the actual service client that we want to use. And then the third one that we commonly add is the model namespace. And that's where all of those request and response classes are defined at. So now let's step into the code here, and let's type out, I want an EC2 client, new Amazon. And we pass in our access key. Obviously, this is not really an access key because they are not fun to type, especially in front of a large crowd. And then we can use those constants to say, I want to connect to US West 2. And now we have our client, and we can simply look, and you see there's all those operations that we can call. And we'll create our request objects and get a response back. So that's a simple way to create it. But here we are embedding our credentials actually in our application. Not really what you want to do. Maybe something for quick testing, but in a real application, you're probably going to push things out to like your app config. So let's just wipe all this out. Go back to just using our default constructor. So now in our app config in the app settings, we can go and add AWS access. And I forgot how to spell access. It's the fear of talking in front of people.
I'll remap the keyboard for you.
That was very cruel. So access key, AWS secret key. And then we can also specify what is the default region we want to connect to. Again, we want to go to US West 2. And so now when the SDK actually goes and needs to sign the request, it's going to go find those credentials in our app config, sign the request, and we're good.
So we have a default region set there. If I instantiate a new client here, say for Amazon S3, but I want to use a different region, am I not constrained by that?
No, like I said, that's just the default. So again, in the constructor, I can go and just say, I want use, and we can go to the new Frankfurt region, right? So even though we have it configured in our client, or in our app config to use US West 2, that's just the default, and you can always override that in your actual code.
OK, so we have no credentials in source code, but we currently have them in the config. Now, I've led a few dev teams in my time, and I know that my developers are going to check that file into source control.
Not a good idea.
Not a good idea.
Right.
So what do we do to help that?
So what we did in version 2.1 of the SDK, which came out last spring, is we added the ability to use profiles. Now, if you've used AWS Toolkit for Visual Studio, we have the AWS Explorer. And you can notice we have already a list of profiles in there. And so we wanted to be able to just specify those profiles in our code. So here I have a few. I can just go in my app config. Let's close this down to give us some more room. Change this to AWS profile name. Change this to norm J. And so now the application, when it's signing a request, it'll say, well, there's no credentials, but you have a profile. So let's go and look to find the credentials for that profile and sign the request with that. And you might have noticed when I looked at my accounts, I have one called default. And default's a special one where if I actually don't specify anything in here, when the SDK goes and needs to sign the request, it says there's no credentials, there's no profile, but you do have a profile registered on your machine that's called default. We'll just use those credentials. And so that's a way to get your application to get its credentials just based on the environment that it's running in and not have to make any changes to your actual application.
So Norm, where are those credentials actually being held?
So for the SDK, we support 2 different credential store. The first one we support is, you can see here in the toolkit, is the SDK store, which is shared between the .NET SDK, the AWS Toolkit for Visual Studio, and the PowerShell commandlets. And this is storing your credentials under your local app data folder. And a nice benefit of using this credential store is it's going to store it in there encrypted based off your current logged on Windows user profile. So if those files were ever gotten off your machine, they would not be able to decrypt them because they can only be decrypted based off that current logged on user. Now, the other way we support specifying credentials is using a credentials file, which I just changed where I was looking at. And this file is shared amongst all the other AWS tools. If you're in a shop that's also using the Python SDK or the Java SDK, you could use this file, and it's an INI file, and all of the AWS tools will use this same file. Now, this is a clear text file, so you do need to be extra careful about how you have access permissions on this file.
Cool. So what I'm hearing then, and hopefully the audience is hearing, is that within the SDK, there's a search mechanism that's going to find the closest set of credentials to use.
Yeah, that's good. So here's our workflow diagram to kind of show how that works. So the top code is showing the code that you're going to write, how you're going to instantiate your client and maybe specify a profile in your app config. And what the SDK is going to do is first check the SDK store. Is there a profile in there? If so, great. Sign your request and continue. If not, let's fall back to that credentials file, the shared file for the other AWS tools. And if we find the profile there, sign the request and continue. We also have a final fallback that we'll use, which is to check to see, are we running on EC2? If we're running on EC2, see if there was an IAM role, an identity and access management role, that was attached to that EC2 instance when it was created. Now, IAM roles are things that entities you create inside either the AWS console or through our toolkit. And what you can do with that is once you create it, you can assign a policy. And that policy is what you can use to grant access or deny access to particular AWS resources or actions. And so that's a great way to lock up what your application can do on a particular EC2 instance. And another nice benefit also is IAM is going to automatically rotate your keys on that box. So you get key rotation for free, and the SDK will automatically pick that up, and you make no changes in your code.
Okay, so that's quite a lot of information on credentials. Let's try and summarize it in terms of development and deployment. So for local development, make use of profiles. You don't need the toolkit to set these up. You can actually call SDK code to create profiles, or you can use PowerShell commandlets. Make use of the profile name in your code, or use default if you just want to use a single set. If you do need to share them, then consider the INI format, but just remember that you need to set appropriate access controls on those files. They are raw. And never put credentials in source code again, or your app config. Just use a profile name. For deployment, use an identity and access management role. So you can specify this when you launch your EC2 instances, whether it be through EC2, through Beanstalk, or through CloudFormation. Taking advantage of the automatic rotation of credentials, no fear. If you do leave the profile name, if you're using a custom profile name in your code or your app config, that's fine. The SDK will just skip that and step straight over it and go for the credentials associated with the role. So we're not going to talk about credentials anymore. All right, we're going to move on. We're going to do the code monkey shuffle and move to another demo.
So the next thing we want to talk about is using Amazon S3 and DynamoDB together with a new feature we call S3 Link. We have found that these are our most popular services that people use from the SDK's point of view. So we really wanted, and it's common to use those together. And so that's what this feature helps people do. So as a quick refresher to make sure we're all on the same page, S3 is the object store. Put anything, images, videos, files, whatever. You put them inside of a bucket. The buckets are globally unique, so only one person in the world gets to have the foo bucket. And once you put that object in there, you give a user-defined key that you will later say, when I want that back, use that key to get the object back. DynamoDB, that's our low-latency NoSQL database. You put your data in a schema-less table, but you do need to define what is the primary key. It's broken up into two parts. First is the hash key, and that's what DynamoDB uses to partition your data across the system. So you want to choose something where your data is fairly evenly distributed so you don't get any hotspots in your data. And optionally, you could add a range key. And the range key gives you the ability to do queries within the scope of a hash key. If you need more advanced querying, there is the ability to add local and global indexes on your tables. When you create your tables, you have to specify what throughput I need from DynamoDB. And this is where DynamoDB is going to essentially grant you that access. And so when you're in your early development stages, you can turn this knob, this throughput, at your low levels. Maybe I only need 1 or 2 reads and writes per second. But now once your application becomes production, you start gaining interest, you can just go into DynamoDB and change that knob. Say, I need more throughput. And your data is still always available as it's going to repartition your data across the new throughput. So for our application, what we've developed is just a simple image storing system. We want to store image metadata in DynamoDB, like the user ID, caption, when it was actually uploaded, and store the actual image inside Amazon S3. So before we get started, though, Steve, I need a table. Can you get me a table?
I can get you a table. So we can obviously use the SDK to create a table. We can use the toolkit. But we thought it'd be fun to actually use the DynamoDB schema builder commandlets from PowerShell to do this. So what I'm going to do is switch away to the PowerShell ISE. And the first thing I'm going to need is a schema object. Now, these schema builder commandlets are designed so that you pipe a schema through a sequence of commandlets to build up the final key, and the hash key and range key schema, an indexing schema that you want, and then you pipe that into a table creation commandlet. So we're going to actually take it step by step today. So I'm going to create a new DDB table schema object. Now, those of you who are wondering what DDB stands for, the PowerShell commandlets are currently, I believe, around 800 commandlets and growing. So to effectively namespace them, we apply a short prefix to each commandlet noun. DDB is what we use for DynamoDB, obviously EC2, S3, something memorable. So now I have my schema object. Let's just take a quick look at that. You can see that it has various fields inside there. So we're going to simulate this photo table. So the primary key that we're going to use is a user ID. The secondary or range key, range key, is going to be the image ID. So let's build that schema. So the first thing I'm going to do is add a key schema. Oh, that's not going to work. You've remapped the keyboard on me.
I like to mess with you.
A DDB key schema, okay. So this time around, I'm going to actually pass in the schema, even though they're designed to be pipeline, just so we can see what's going on. $S, and I'm going to add a key name, and it's going to be user ID. And then I'm going to add a key type, or actually let's use key data type to start with. So this is the type of the key, so string, S, number, N, etc. And then there's a key type, and we're going to specify this is the hash key. So when we get the schema object back, you can see that the PowerShell commands have filled out the attributing and the key index, the key information. So now we need another key. So I'm going to invoke that. I'm actually going to invoke that again. And this time I'm going to pipe the schema in. I seem to have developed an echo. And we're going to give the key name. This time is going to be image ID. And the key type is going to be range. And the key data type is, again, just going to be a string. So you see we've got both keys set. I could go on and build indexing, etc., but this is enough for what we need. So now let's just pipe that straight into new DDB table. And we'll give it a table name. And I know the code requires something called image metadata. And just for this demo, I'm just going to use a simple provisioning of 1 and 1 for read and writes. So that will run. Pregnant pause.
What would you do, Steve?
Have you taken my demo out again?
I was trying to be sneaky.
All right. We're actually connected to wireless, so we're probably being slow. Okay, well, while that's finishing up, let's switch away to the code, and then we should get our table up and running. This is the demonstration of Gremlins, isn't it? Okay, here we are then. Here's the code.
Okay, so for our application, we're going to use DynamoDB, as we said. And Steve mentioned earlier that we have some high-level abstractions for across the SDK. And for DynamoDB, we actually support 2 different high-level abstractions. One we call is the document model, where you create these document objects that kind of like .NET dictionaries. You set values on there, and you use a table object to persist them. The other one we call is the Object Persistence API. And that's where you can take .NET classes with annotations and using a context object, be able to persist the instances of that class in DynamoDB and be able to get instances of those classes back out using that context object. So you can see here I've got the image metadata class. It's got an annotation to say which table we want to store it in. And we also have just annotations to say which properties map to the range and hash key.
Hey, Norm, these names match what we used for the table creation. Can't we just take these out now?
We can, actually. That was one of the features that we've added this year, is if the names in your C# code match the same names you're using in DynamoDB, we'll just infer that relationship. And so that's where you can just use just plain POCO objects, C# classes, and not have to add any special attributes. If your names differ, then you might need to use the attributes. There is also another alternative. In the app config file, you can actually add a mapping in there. We're not going to go into that right now, but it's out there, and there's some documentation on our website on how to use that.
Okay, so here's our simple POCO class, and pretty standard stuff, except at the bottom you see an image thing called with type S3 link. So that's the new feature.
Yeah, so that new type is what we use to store the information in DynamoDB about where things are actually stored inside S3. So did we get our table, Steve?
I'm hoping so. No, we did not. Name resolution failure. Uh-oh.
Interesting.
Let me just run that again, just see if it comes back. I don't think it will. This is going to be a short demo.
How about we trying to reconnect and disconnect and reconnect from the Wi-Fi? Well, now you have to type it in.
That's true, I do.
It makes the demo so much more exciting when you get these issues.
You know what? I've never done this in a live demo, but yanked an Ethernet cable out the back of a machine.
Now that you've pulled that out, why don't you?
Let me just get rid of that. Let's reconnect. See if we can do this. Okay, hopefully we now have a network. Now your keyboard's died on me. What kind of machine is this?
The same as yours. You mean run.
Right, I meant right.
Capacity.
I wrote run. Hey,
Hey!
table. You can see table
was
status
gonna
is
get scary.
creating. Okay, so DynamoDB is now provisioning the table rapidly as I speak. I didn't capture the table object that was returned, but if I wanted to check it, I could just use getDB table with the table name. It would give me all the current information, but I'm pretty sure that table is ready to go.
Yep. So now let's look back to our code here.
Okay, so it's occurred to me that apart from that rather lame bit of PowerShell, we hadn't actually run any code, so shall we step through this?
Yeah, let's do it.
All right. So F10. So here we are inside main. So instantiating an S3 client, this should look fairly standard by now, but DynamoDB context, that does not look like a client to me.
No, that is the root object. When you use that object persistence API, this is the root object that you use to save and get those instances of our image metadata class back out. Under the covers, it's going to go create our DynamoDB client library, or client, service client. We could also, if we had one already, we could pass that in to reuse the client. It's important to know whenever you use the context object, though, that when you're going to first make a call to a new table, it's going to do a describe table on the table in DynamoDB, which is not an operation you want to do for every single request. So like in your web server, every request coming, you don't want to describe table every time. So this is something that you want to cache around. It's a thread-safe object, something just to store somewhere easily accessible.
Okay, so then we're going to create a test bucket. So Norm said earlier, buckets have unique names. So this is a common pattern that we follow in our testing. We create a bucket, and we append the current date time in ticks to the end for uniqueness. So very simple. So then we're going to instantiate that plain old C# object that we saw, the image metadata. Special bit being the S3 link create here. Norm, do you want to walk us through that?
Yeah, so we're going to call that create method, and that's what we're going to pass in. We can say what bucket we want to store the image in, what is the object key to store it with, and what region is that bucket in. You could actually have your bucket be in a different region than your DynamoDB table at.
Okay, and then we call save. You can actually invoke save without the type, generic type in there. It'll infer it, but we'll keep the code simple. So right now, that's just saved the image metadata to DynamoDB. The actual image is not yet in S3. So let's go and take a look at DynamoDB, at our table that caused us so much issue. And there we go. There's the entry that we just wrote. I'll just blow this up for you. And as you can see, that it's just a piece of JSON, effectively.
Right. So we serialize that S3 link into a JSON object, stick that in S3 or DynamoDB. It's also important to know that if you're in a shop that's also using .NET and Java, the Java SDK has this same feature, and we use the same format. So you could use .NET to upload and maybe Java to download that object out. We do have that interoperability.
And then if we go and take a look at the buckets, and you can see here that Norm has a habit of grabbing all the bucket names.
You're always making fun of my stuff.
There we go. We have an empty bucket right now. We have not yet saved the image. So let's go back to the code. And to actually upload the file, we call through the S3 link object. We could also use the S3 client, but let's use the S3 link. And there we go. So if we go back to the bucket now, go back to the bucket and refresh, there's the file. Okay. So then to get things out, it's just as easy. So we use load on the context object. This time we do have to pass in the type as the generic. And that's given us back our console caption. And then it looks like to get the image back, we're going to use a pre-signed URL.
Right. With that S3 link, we could either upload new objects, we could download the objects. Another great feature of S3 is we can generate pre-signed URLs. And this is really useful for when you're in a situation where you want to grant access to somebody or maybe to some other process, temporary access to an object. In this case, we're going to grant access to this object for an hour.
Yep, 1 hour. There's the pre-signed URL. It's just mangled. And I'm just going to run the rest of the code to actually open the URL.
Okay. Here's the shameless plug of my daughter, who's convinced she's the #1 girl out there.
All right, back to slides.
You can see S3 link is a great way to easily tie these very popular services from the SDK's point of view.
Onwards.
So for our next demo, we want to talk about using Amazon Elasticache to create distributed cache clusters and be able to use these cache clusters to help improve performance you might have in any sort of bottlenecks in your application. The reason Steve and I are talking about this is because just recently, I believe it was just 2 weeks ago, we launched a new library on NuGet to be able to extend the popular memcached library Inium to work with Elasticache's unique ability to dynamically add and remove nodes to our cache cluster. And we won't have to change our code whenever we get new nodes or remove nodes from it. So I know I've been in this situation in past jobs, and I'm sure a lot of us have been in this case, where we have a bunch of web app servers all pounding down on a single database server, and eventually that database server has a hard time keeping up. So the first thing we always think about is, well, let's just add more caching so we don't pound on our database server so much. The tricky thing, though, is if you put caching on your app server, one app server might cache the information, but another one's going to change it. And then how do you get everyone in sync? So a common way to do next is you use a distributed cache system like memcached. And Amazon Elasticache is an easy way to create these clusters in a managed way so we don't have to specifically install software or get these instances all connected together. Elasticache handles that for us. And so we can change our application to say, first, let's check our fast cache. Is the data in there? If it's not, then we'll fall back to our database. If it is, it's got it, let's return it back to our user. When we go fall back to our database, we'll then put it into our cache cluster, so the next request comes in on any one of the web app servers is able to access that data in a much faster way.
All right.
So how do we get started, Steve?
Well, we get started by first creating an Elasticache cluster. So
we haven't talked about what we're going to demo, though, yet.
that's true.
I skipped that part. Very sorry. So to demonstrate this, what we've done in our for our demo is we've created an application that stores zip code information. I think we've already deployed a Beanstalk, so let's go see what it looks like. We have.
So yeah, the reason I'd forgotten about your application was it was so simple. It's just.
Hey, I have great UI skills.
All right. So anyway, all we do is we enter a zip code, and Norm's code will run away, get the location, and return a map. I mean, that wasn't that fast, right? It didn't actually return a lot on screen.
I'm sorry. Well, let's look at the code and see what's going on. So for this application, I just use standard .NET technologies. I'm using a SQL Server database, using an entity framework, and pulling out the zip code information and returning that back. Notice in my code here, I'm using some trace statements so I can measure the performance. One of our extension libraries that we have on NuGet is to be able to have all your trace statements be written to DynamoDB. So it's easy to see that information outside of your environment. Let's go see what our log table is showing us.
Okay. So here's logs. Open it up, and I don't know if you can see that at the back. Let me blow it up. We retrieved that zip code in 1,124 milliseconds.
OK, now this is the full confession here. Because it's just Steve and I hitting one application, so we need to simulate a performance bottleneck. So what we did is we put our database out in Sydney, and our application is running over in Portland. So a bit far-fetched, I know, but,
hey,
but still, let's make it better.
All right. All right, so first thing we need to do then is add an Elasticache cluster. So I'm going to go off to the console. Now, because we had some gremlins earlier on, I'm not actually going to run through the Elasticache launch cache cluster wizard. We'll skip over that today. Here's the cache cluster that we actually created for the demo. Was that you or me?
I didn't do it.
Called zip codes. It has 2 nodes, memcached type. And the information we actually need to set up our code is this configuration endpoint here, zip codes, dot, blah, 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 etc. So that's what we're going to need in our code. Okay? Then all we need to do to our code is to add a new extension library that Norm mentioned. So if we go to the NuGet, here's all the AWS SDK for .NET extensions. At the bottom, you see this new one here, Amazon Elasticache Cluster Config. So once we've added that to our code, let's jump into Solution Explorer. And if we look at the references here, you can see there's the new package. And that automatically brings in a reference. I'm going to have to take this microphone off in a minute. Automatically adds a reference to the third-party Enium caching library. Okay? So that's the first easy bit. So the second bit that we need to do then is add information to web config about the new cluster client library here. You can see the new section name, cluster client, mapping to our new NuGet package. So Norm, do you want to walk us through this?
Sure. So here's, we're going to set the host name and the port that we got from the console. And the other thing we need to set is actually we don't need to set this, we're just showing, by default, the interval polling we do is every minute. So what our client does is every minute it's going to ping our cache cluster to see, is there a change in your configuration? Have you added new nodes that we need to take advantage of, or has some nodes been removed so we need to stop actually using those? Once we find out that new information, we pass that up to Inium, and Inium's now going to adapt to the new nodes in its cluster.
Okay, so in the code, hotness, really?
Yep. I just wanted to see if I can embarrass you.
Okay, so here I can see we have memcached client and a new Elasticache cluster config. What are those?
Right, so the config object is what we added. That's going to pull those values from the app config. If we didn't set it in the app config, we can actually manually set it on the properties of the config object. And we pass that config object to Inium's memcache client. And so from after that, you're going to be working just as if you're normally using Inium. Nothing special about us. We're just being taken care of by that config object.
Okay, so here's the new get for the zip code. So you can see that again, well, we set the daytime before it starts so we can check performance. You see here we're calling on memcache client to get the zip code. If that returns something, great, we're done, we're out. If not, go to our regular database server, get the zip code data from there, then store it in the memcache client cache, write the trace, and then off we go. So should we try it?
Let's do it.
All right, so let's go away in the toolkit to the deployed hotness.
Mm-hmm.
Here we go, restock environment. So we click the link and put in the same zip code. And that didn't seem much faster to me.
Well, let's check the log again. Let's see what's going on.
Go back to the logs, scan the table. You can see now we have two entries. One to indicate that we had a cache miss, so we've stored into the cache now, and then we retrieved it in 1,156 milliseconds.
Not very fast, but now it's in the cache. So now let's try again and see what happens.
Okay. Ah. Okay, zip codes. The truth is out. Here we go. 15 milliseconds.
Right. Now, who wants to tell their boss that I made that performance benefit?
Okay, cool.
With just a few changes in our code.
All right.
So here you can easily see, by using memcached and Amazon Elasticache, we can easily fix some maybe performance bottlenecks they have in our application.
Okay. I think it's time to do the code monkey shuffle again.
Okay.
All right. So earlier on, I said that we were not going to talk about credentials anymore. Well, that wasn't strictly true, so I apologize. We considered local development, we considered deployment, but we didn't consider mobile applications. So deploying out to an app store that we have no control over and the ultimate mobile devices that they go onto. Obviously, we don't want credentials on those devices, and an identity and access management role probably isn't going to be what we want. What we need is for the clients in our code on those devices to retrieve credentials as they run. So earlier this year, Amazon launched Amazon Cognito, a user identity and data synchronization service. What we're going to do inside our code is use the user identity part of that to show how we can easily add the idea of getting credentials on the fly on a mobile device. So Norm, how easy was it to do?
Well, it's very easy, Steve.
I'm glad you said that.
But what we do in, actually,
Are you not going to show the app first?
Let's show the app first.
Because
I
your
do
UI
need to do
skills are
some
improved.
resolution craziness. Apparently, our projector does not like the resolution that Windows Store apps require. So excuse us while it looks very squarish for a few minutes while we talk about this. So, meant to go all the way. So let's go ahead and launch that.
Your usual UI skills.
They're awesome, man.
That's an improvement.
See, yes. So here's our photo viewer application. These images are actually stored in S3, but the user never logged on. And this is where we wanted to support the ability for people to have never access, be able to at least see what's actually in there. Now, once we actually want to change something, like if I want to upload an image, then we want to challenge the user. You're going to change something, we got to authenticate you. Who are you? So I'll go ahead and log on to Facebook. And so now I'm going to be able to upload new images over our Wi-Fi. There we go. So there you can see that's kind of that pattern where you want users, when you write an app with zero friction, of at least come in and see the data in your application, and then once you want them to contribute to the community, actually log on to something. So let's shut this down and switch down our resolution to something that's not so ugly out there. We good?
Yeah, we're good.
Okay. So to get this to work, what we used is the Cognito credentials provider. That's this Cognito's class right here. It comes from the Amazon Cognito identity namespace. And let's walk through what you need to specify to create this object. First, we need to specify what is the account number that we're accessing. And the second one is this interesting looking string. It's called the identity pool ID, which is something you create inside Cognito. So let's go over to the console and take a look at that. So Cognito is actually only in US East 1 and EU, the Dublin region. But it's important to know that when you're using the credentials that are vended from these services, those credentials are valid across all of the regions. So for our example here, I'm connecting to Cognito for US East 1, but when I create my S3, I'm actually using US West 2. So we'll switch over there. Already created my identity pool. We'll take a look at that. Cognito is going to give you a good dashboard information about how many unauthenticated users have come in, and it also tells you each of your authenticated providers, how many people logged on there. Going. So we'll take a look at the details of that. There we go. So there's that identity pool ID. That's the part that I put in my code. And then after that, we specify what are the identity providers that we want to support. We support Amazon, Facebook, Google, also any OpenID compliant providers, as well as you can create your own developer authenticated identity providers. We're using Facebook for our application today. You can actually use any combination of providers that you want to use. And the last thing I want to show here is this checkbox to say I want to enable access to unauthentic identities. And that's how we're able to get people to come into our application and see the images in S3 without actually logging on. So the last two parameters we got going on here these are identity and access management roles. These are the roles that we're going to assume when we do things. The first one here is our unauthenticated role. Let's take a look at that in our toolkit here. You can see unauthenticated role. What this role is going to grant the user is the ability to, first is to add access for the mobile analytics, and after that to be able to get objects from S3 and list the objects for S3. The authenticated role has those same permissions, but we've added the ability to delete objects and put new objects inside S3.
Norm, I'm feeling a malicious streak coming on.
You're always malicious.
What if I got hold of your code and I switched those two roles around? Do I suddenly get the ability to operate in an authenticated manner?
That's not very nice. So yeah, if you tried switching these two around, you would get 403 forbidden access. And the reason how that works is if we go back to our console, we switch over to IM, look at those roles. Here's our authenticated role. And down below, there's this trust relationship. This is what Cognito set up for us when we created our identity pool. And it has these extra conditions right here that's saying that in order to assume this role, you have to be authenticated from Cognito. So just trying to switch it to use it for an unauthenticated view would be getting your access denied errors. Sweet. So now that we have our credentials provider, we pass that to S3, and then from there we can use S3 as we normally have been doing. Now to show how we switch users to unauthenticated to authenticated, let's look at the upload operation. And I have this utility method to make sure that I have logged on. So if I look at that, I'm going to go check that credentials provider. Are there any current logon providers? If so, then the current user is already authenticated, so go ahead and return. If there's not, let's run some Facebook code to get our OAuth token from Facebook and pass that on to our credentials provider, which is going to go work with Cognito to switch from using your unauthenticated role to start assuming the authenticated role for making our operations. And then we're going to be having access to that delete and put operations. So you can see here's the delete code, same situation. And you can see after we've ensured, We're just going to use X3 client to do a delete operation as we normally do. So there you can see an easy way to use Cognito to support that very common use case of unauthenticated users for read access and make them authenticate when they actually want to change information.
Okay, cool. Right, back to the slides. So that brings us to the end of the demos that we wanted to show. Before we leave you, we want to have a quick word about open source and community, etc. So some of you may know, some of you may not. The SDK is open sourced. It's held on GitHub in the AWS-SDK-net repository. What you may not know is that, obviously, at the keynotes yesterday and today, there were a tremendous number of new service launches. So to keep up with that pace, we rely on code generation for the service client API layer of the SDK. So we actually open source the client generator that we use today. Also a batch of unit tests in there that you can run that test the output of the generation in terms of mock requests and responses based on the service models. You can run these. There's no charge. They don't spin up any AWS resources. They don't actually make any calls at all. There are some integration tests. Now, these do call AWS. They do spin up resources, so there is a monetary impact. But they can also be used as a teaching exercise of how the code works. So feel free to take a look at those. The team welcomes pull requests, and we also monitor the GitHub issues. So if you have any concerns, questions, etc., put them there. If you're not a GitHub user, you can use the AWS forums. So there's a forum for .NET development. You can post SDK questions in there, Toolkit, PowerShell, etc. But there is a PowerShell scripting forum that stands alone. The team also monitors the Elastic Beanstalk and CloudFormation forums if you have questions about deployments from Visual Studio, for example. And of course, there's always Stack Overflow. From us to you, there's the .NET development blog. So we have some posts on there that we've done recently. There was a series on Amazon DynamoDB recently. We've also blogged about the new Elasticache cluster client. And earlier this year, there was a post on importing VM images using both C# and PowerShell. And of course, you can follow us on Twitter, the AWS for Net handle. So that brings us to the end. Thank you all for coming along. I hope you enjoyed it. Please remember to fill out your feedback. It's very important. And I hope you all have a great time at the party tonight. Thank you very much.